Hello, I am Pete Demar with Battery Research and Testing, and I will be narrating this session of our stationary battery maintenance tech tips. This is tech tip number 3, recovering failing VRLA cells with the IOVR Plus process. Just as an explanation of why it's called the IOVR Plus process, when we first started trying to recover VRLA batteries by resaturation only, the very first thing that we would observe would be an improvement in the internal ohmic values. Sometimes you would see the start of an improvement within minutes of the water additions. To visualize how it is possible for changes to occur this rapidly, think about a kitchen sponge that is dried out after usage and has shrunk. Then let it absorb water and notice the difference in its size. This is the same concept but different. The AGM expands and improves contact between the plates and improves the compression in the cell. The next step that came along was the inclusion of a catalyst into the headspace, which increased the length of time of the improvements. Because of this, we dubbed it the IOVR, which stands for Internal Ohmic Value Recovery. We added the plus to the IOVR once we realized that by coupling the resaturation with a high rate charge, that the amount of improvement from the as-found capacity or capability would be quicker and often more substantial. In this tech tip, we are going to explain how and why the IOVR Plus process is able to restore capacity and runtime to VRLA batteries suffering from PCL, which is premature capacity loss, while also reducing the required float current, lowering elevated cell temperatures, and reducing the risk of thermal runaway. Every manufacturer of VRLA batteries understands and will acknowledge that if a VRLA cell or battery off-gasses to the point of being in a dried out condition, that it will have a degraded capacity or capability, plus have degraded internal ohmic values, plus have an increase above normal in its required charging current, and will be at a higher risk of thermal runaway. As recently as March 28, 2020, EnerSys, in their recent webinar covering lead-acid battery failure modes, listed dry out and lack of compression as the very first item under typical failure modes for VRLA batteries. When these cells off-gas to the point where they are dried out, the AGM or gel actually shrinks somewhat, and there is a loss of contact between the AGM or gel and the plates. This also creates a loss of compression inside the cell, which is necessary for the cells to function properly. There have been a number of papers presented that explain these conditions. Because of that understanding, a number of manufacturers install catalysts in their 2-volt cells at their factories, and some offer them as an option, but do not install them at the factory. They ship them with the cells for installation in the field. There are also some manufacturers that install catalysts in their 12-volt units that are specifically designed for high temperature applications. This is because of the importance of recombining the gases inside the cells to maintain the moisture in there. For models that do not come with catalysts, there are catalyst-equipped vents available for pretty much any manufacturer's units. With most 2-volt cells, it is a simple do-it-yourself process to replace the existing non-catalyst vent with one that has a catalyst in it. Let's go back to this tech tip. Degraded capacity or capability that occurs earlier in life than the design life is referred to as PCL, premature capacity loss. The IOVR Plus process was created in order to help users of batteries that were suffering from PCL. The IEEE 1188A 2014 document refers to the process performed to accomplish this recovery as the special recovery process. In case you are thinking that this is some new smoke and mirrors type process, you need to understand that our first attempts to recover batteries that were suffering from dryout were performed back in 1995 and 1996 for United Telecom in Florida, and only included the addition of varying amounts of water to the cells. Though we were able to make improvements in every string that we rehydrated, and all recovered from less than 80% capacity to passing their follow-up capacity test, the adding of water alone was not a long-term solution. Within 2 years, the internal ohmic values and capacities were again degrading. The report on that initial work was published at BATCON 1997. PCL back then was a worldwide problem. It did not matter whose battery it was, or from where it was manufactured, or the conditions it was operating in. It would suffer from dryout way early in life, which resulted in PCL and very often thermal runaway. Since it was a worldwide problem, manufacturers, scientists, and research people from around the globe were trying to understand why this was occurring. The plates that were being used in VRLA cells were basically the same plate designs that had been in use for many years in vented cells. So it was understood that the design of the plates could not be the root cause of the problem. The only real difference was in how the electrolyte was immobilized. This was accomplished by either gelling the electrolyte or by using an AGM, absorbed glass mat, to absorb and hold the liquid electrolyte in contact with the plates. European manufacturers utilize the gel technology predominantly, and in the US, the AGM technology is the primary design. As mentioned, this was a global issue, with much money and ideas being thrown at it. However, the root cause of the problem was not understood until the research that was being led by Will Jones at Philadelphia Scientific, in conjunction with Dr. David Fader and Dr. Dietrich Berndt, discovered that the negative plates were becoming undercharged during normal float operation. This is when the microcat catalyst was first created, and it was developed to fix that problem. I'm not going to go into the science behind their finding, but if you'd like to read the multiple papers that documented their findings, please contact us at info@batteryresearch.com, and we will gladly provide them to you. Of course, you can also find their published work on the web. The result of the negative being undercharged or underpolarized is that they actually end up being discharged. Because they are being underpolarized or undercharged, this means at the same time, the positives are being overcharged, which makes them age more rapidly than they're supposed to. That breakthrough by Will Jones was a missing piece of the puzzle, as by having a catalyst helping control the negative polarizations, it enabled the resaturation that we were doing to become a long-term benefit. This undercharging to the negative plates is not obviously evident to anyone, because the float voltage of the cell is right where it's supposed to be. However, if you are monitoring the float current, you will see that it is increasing over time. Or, if this is your first time inspecting the battery, you will find the float current elevated above what it should be for that model cell. This will be causing an abnormal rate of off-gassing, which is what causes the dryout of the cells. If you do not know what the typical float current should be for your particular string, just contact us and we will share what we know. You also can contact the manufacturer of your model cells or use the IEEE 1635/ASHRAE21 spreadsheet to see what your type of cell should have as a normal float current. If an elevated float current is left unaddressed for a long enough time, you will notice that the temperature of the cells will be above the ambient temperature. A battery that is more than 3 degrees Fahrenheit above the normal ambient is cause for concern. You will also see a degrading of the internal ohmic values because of the changing of the contact between the plates and the AGM or gel, caused by the reduction in the moisture in the cell. Water has been lost from the cells. The first step in the IOVR Plus process is a detailed inspection, which includes a pressure check of each cell to verify its integrity. This is a critical part of assuring that the process will make improvements to the string. Depending upon the internal ohmic results, we may or may not perform a borescope inspection on the internal buswork and internal posts. The next step is resaturation of the cells, based upon the individual cell ohmic values as reference to our history for that model and age of cell. This is done with a digital dosing pump. Each of the individual cells will have varying degrees of dry out, so each receives the appropriate amount of saturation. Next is the installation of that particular catalyst-equipped vent that is used for that particular battery manufacturer cells. There are numerous different vent sizes. Last but not least is the application of either an equalized charge or boost charge. These last two steps can be applied in either order, and the rate at which the boost charge is applied is dependent upon the condition of the cells prior to the initial resaturation and site-specific issues. It must be understood that there are some cells or strings that are beyond being able to be recoverable for a long term. However, if they are structurally intact, we can make improvements that will allow the battery to continue to be used for some limited period of time. By limited period of time, we mean a few years. There are a number of papers that have been presented by users from all over North America that explain their success with the process, to include even how strings were brought back from a thermal runaway into useful strings, and some describe the substantial savings they realized by recovering their strings instead of replacing them. Because of the success that we have had since the addition of the catalyst and the high rate charge, we offer a guarantee that if we do not make improvements to the cells, then there is no billing. Basically, we are putting our money where our mouth is. Hopefully, this has helped you understand the IOVR Plus process a little better. If you are interested in understanding more about what we do or how we might be able to help you, please go to www.batteryresearch.com and look around. If you would like to be notified when we release a new tech tip, please go to info@batteryresearch.com and tell us to notify you when we release a new one. Or if you just have a question on a stationary battery subject, just do the same. Oh yes, if you have any experiences or pictures of unusual things that you have found, please share them with us so that all of us in this industry can benefit each other. Have a great day, stay safe, and stay healthy, and thank you.